Hello and welcome to our Craig M. Burge Design Day presentation. We are Team 19096 and the title of our project is a Submersible Optical Test Station, or what we will refer to as SOTS. Our team consists of 6 engineering undergraduate students. Our electrical engineer, Alex Sisson, our mechanical engineers, Patrick Baker, Zachary Schiff, and Kevin Partita, myself, Matthew Fisher, studying engineering management, and our optical engineer, Isaiah Engel. This is our Design Day poster. Here you can see our project's goals, components, and final design. We shall cover each section in more detail within our presentation.
Our project is sponsored by Arete, which is a defense contractor that works across the electromagnetic spectrum. They develop sensors and the associated signal processing algorithms necessary for the extraction and interpretation of data for systems operating underwater, in the atmosphere, and in space. Our task is to create a submersible optical test station that will be used to test the optical equipment underwater. Every optical device that Arete designs has to be manually tested in the water. Currently, Arete, when designing a new sensor, has to create a new platform to test each individual sensor. This process of creating a new platform every time they want to test a sensor has proven to be unreliable and inconvenient. Therefore, the goal of this project is to build a prototype submersible optical test station. This test station will be used to test multiple sensors that Arete creates in the water. The way this system will work is there will be a user on top of a boat. This user will have access to be able to control an ROV under the water. The way he will control the ROV is through a game station controller that will be connected to a laptop. The laptop will have a display, and so you'll be able to see everything that the ROV sees under the water. The laptop will be connected to the vehicle through an umbilical cord.
The road to our final design was not a simple one. We have highlighted some of the obstacles in this slide. From our first design, it can be seen that a lot of these key features were not thought through yet. The first design was designed to illustrate the most basic goal. That is, how does everything piece together? It is clear that ideas like stability, buoyancy, and drag were not thought through. Moving on to our next design, it can be seen that ideas were starting to click. We added some fairings to help with drag, and we had a quadcopter design for stability. We kept the concept of having one main hole running down the middle. This gave us the option of mounting the payload either on top or the bottom. However, when mounting on the top, we did not consider the weight of the payload would have the tendency to move towards the bottom of the ROV. This led us to the main feature of our final design. Having 2 holes for the electronics at the front and the bottom end to allow space in between for mounting our payload. We kept 4 vertical motors and 2 horizontal motors. This sacrificed speed, but saved us a lot of headaches on reasonable amount of power that would be needed with 4 horizontal motors.
In order to complete this project, a lot of prototyping was necessary. For one, creating a full-scale wood model out of particle board was one of the things we did to prototype. We did this to determine whether we had any problems with wiring, how all the wiring should work, where we should mount things, and if our 3D model was similar to what we expect in real life. After completing our prototyping with our particle board, we were comfortable with sending out quotes for our aluminum to be manufactured for our plates. And once we received the aluminum, we painted the aluminum with marine grade paint to prevent corrosion, and we tapped in holes on the sides to allow for threaded screws to go in. We then assembled all the mechanical and electrical components to move on to the next step of the electrical integration.
Everything inside the dotted box is components that we provide, and then the laptop that's outside is provided by the customer. So inside our box, we can see we have a gaming controller that is used to control everything. Then the laptop communicates directly with a Fathom X. The Fathom X is there to amplify the signal from the Raspberry Pi to the laptop. The Raspberry Pi is for relaying the signals between the laptop, the GUI, and the Pixhawk. And then the Pixhawk communicates with all of the sensors, the LEDs, the thrusters directly. So the depth sensor is just connected to the Pixhawk with I2C communication protocol that allows us to detect what depth we're at, and then it relays that information to the Raspberry Pi, and then that goes up to the laptop. It's the same thing with the LEDs, what our current light level is, because we can change the brightness. Everything inside of the submersible is powered directly from 2 lithium-ion batteries wired in parallel. Those go to a power sense module, which then distributes power to all of the components through a power distribution block. The PowerSense module is also connected directly to the PixHawk, and that allows us to determine what battery life we have left.
Here is our requirement verification table. As you can see, we have our system requirements, our verification method, and whether we passed or failed. For the pass or fail, we have that all of our requirements have passed except for our few TBDs. These TBDs are TBDs because of COVID, and we were not able to test. Now going the deliverables to our sponsor, highlighting a few key things that we have. On May 5th, we are going to be delivering our acceptance test documents, our software design document, and our technical data package, all through PDF, and will be delivered to Google Drive to John Hunt. And the physical device of the SOTS will be dropped off to Airte on that same day.
Okay, this project, like many projects, had a lot of surprises and problems that we had to overcome. The first of which being the coronavirus. The coronavirus obviously caused a lot of problems. For one, Airte would only allow me, Patrick, to go in because I'm an intern there currently. Since that was a problem, we didn't have a chance to assemble it as a team. So to combat this, we decided to split the project into a bunch of one-man teams to get everything integrated to the best of our ability. Another problem we had was the budget. The budget was probably the biggest issue of this project. We overcame this by talking with our sponsors. And after talking with our sponsors, we were able to lower the scope of our project, and Airte was kind enough to comp our shirts, and they would comp our machining, which were huge portions that would cause a budget issue with us. We also reached out to Blue Robotics, and they were kind enough to give us a 10% discount and a free tether. The last issue that I'm going to speak about is drag. Drag caused many problems. It made it super hard for our vehicle to move within the water and meet our original requirement that was 5 knots. To reduce this, we decided to switch from rather a umbilical for power, we switched it to batteries. And we still kept an umbilical for electrical signals up to the boat, but it is much thinner, which reduced the drag.
So for our conclusions and our path forward, we recognize that the SOTS remains incomplete due to COVID-19 complications. However, the mechanical assembly has been completed except for the penetrators. The electronic wiring has also been completed, and all of the software has been installed. The PixHawk LEDs, the controller, and laptop software have all proven operational. The calibration has also been completed for all of the sensors. So in our path moving forward, we're going to supply Airte with the SOTS and its current completion state. Some things that need to be done, however, is the Raspberry Pi 4 needs to be replaced with the Raspberry Pi 3B in order to communicate with the PixHawk and laptop. This was due to a bug that exists in the Raspberry Pi 4, causing the software to not communicate as needed with the laptop. And we are also not able to complete the pool test due to COVID-19 restrictions.
This will conclude our Craig M. Burge Design Day presentation. Thank you for listening, and we will now take any questions.